In this demo, we'll protect and recover a PG vector database running on Red Hat OpenShift with Veeam Kasten. This environment is an OpenShift cluster running container and VM workloads. For this demo, the key workload is a cloud-native Postgres cluster with the PG vector extension enabled. PG vector is commonly used by AI applications to store embeddings for retrieval augmented generation, or RAG. The database is running as a highly available Postgres cluster in its own namespace. Kasten is also installed on the cluster and has already discovered the applications running across OpenShift. Now, we'll protect the PG vector workload. In the Kasten UI, I'll open the policy for the PG vector demo and run it on demand. I'll also set an expiration date so this recovery point does not live forever and consume unnecessary storage. This policy is doing more than a basic snapshot. It is configured to protect the PG vector namespace, create a backup, and export that backup off the cluster to object storage. That gives us a real recovery point outside the local OpenShift environment. The important part is application consistency. This policy uses a Kasten blueprint to run a pre- and post-action around the backup. In this case, the backup is taken from the secondary Postgres replica, not the primary. The pre-action pauses the replica, Kasten captures the data, and the post-action resumes it. That helps avoid impact to the production writer while still giving us a clean backup of the database. Now the backup has completed successfully. Before we simulate a failure, let's confirm the database has data. Here we can see document embeddings stored in PG vector. Next, we'll simulate a bad event. This could be an accidental deletion, a rogue administrator, or even an AI-driven workflow that changes or deletes the wrong data. I'll drop the embeddings table and confirm the data is gone. At this point, the RAG application would lose access to the context stored in the vector database. Now we'll recover with Kasten. I'll go to the restore points for the PG vector demo and select the most recent recovery point. For this demo, I'll use the local restore point, but the exported copy could also be used if the cluster copy was unavailable. During restore, we use the same blueprint to run a before action that deletes the cluster resource first. This is important because the operator will otherwise try to recreate pods and persistent volumes while Kasten is restoring them. Removing the cluster resource, or CR, first allows Kasten to perform a clean recovery. Kasten restores the Kubernetes metadata and persistent volumes, then the Postgres cluster comes back online. Finally, we'll verify the result. The restore is completed successfully, the Postgres cluster is running again, and the PG vector embeddings are back. This is how Veeam Kasten can protect and recover PG vector databases running on OpenShift AI, including application-consistent backup, off-cluster export, and clean recovery for AI and RAG workloads.